This is a video demonstration for Young's double slit experiment. Firstly, the materials that we will require. We will require a pair of scissors, a roll of Scotch tape, and any kind of opaque tape. We'll also need a flashlight. It can be any flashlight, a torch, maybe the flashlight on your mobile phone, that could also work. You will need a black marker or a pencil and a piece of paper. You can also use some aluminum foil instead. I will go into details about this later. And you'll need a knife or a scalpel. You don't need to use a scalpel because if you're not able to make fine slits in your piece of paper aluminum, I will show you a method later on using a piece of wire. You can also use some kind of straightened stapler pin. You'll also need some newspaper. Right, so the first step is that you're going to roll up your newspaper into a cylinder and tape it so that it remains a cylinder. I'm just going to, as you're showing here, I'm just taping the edges so that it doesn't come apart. It's pretty simple so far. The next step is that you're going to use your piece of paper and blacken it with any kind of black marker. You could also use a pencil, but I've seen the pencil doesn't yield results as good. You're going to blacken it on both sides, and this will act as our screen that does not let any light pass through it. So when we make a hole in this kind of paper, the light will only pass through that hole and will be blocked by how dark the rest of the paper is. You can just use an aluminum foil, that should work just as well. I didn't have aluminum foil, but this was the next best thing. I'm going to cut a piece of this paper and tape it to one side of the cylinder. Next, I'm going to find out approximately where the center of the cylinder lies. You don't need to be that precise with it because the hole from which light enters and the two slits that you make on the other side should more or less coincide with each other. So I just drew two perpendicular lines and made a hole in the middle. Now here's a trick if you're not able to make a hole that small. So I wasn't able to make a hole that small even with a needle because it just wasn't succeeding in making my light any close to being coherent. So what I did was I took some pieces of tape and I taped them to the sides of this hole so that they lie really close to each other without touching each other. So this will create this will leave just the slightest space in the middle from which your light can enter. And I have, in my try of this experiment, this worked better than just poking a hole with a needle. So in the next step, I'm going to use the same paper that I made in one of the previous steps and tape it to the other side of the cylinder. Going to make two perpendicular lines the same way as I did before to find out approximately where the center lies, and going to make a slit in the middle. Now, you probably won't be able to make a slit that thin, and especially two slits that thin. That will definitely tear your paper, aluminum foil, or whatever. So I recommend that you make only one slit and then use a wire. So this was a wire I found just lying around my house. It's one of those cords that you find in a phone box where your headphones are tied up. If you have a pair of headphones, the wire is usually tied up with this cord, and inside you can find a really fine wire. You could also just use a stapler pin that you have straightened. Basically what you're going to do is you're going to take this piece of wire and use tape to place it over the hole that you have made, and then you're going to use two more pieces of tape to place it as close as you can to the wire without touching it. This will create two very fine slits that will help you observe the diffraction pattern. This is what the apparatus looks like when I'm done, and now I'm just going to tape it to my phone screen. So I did it in this way that I observed the light in a dark room coming from the side which has the double slits, and wherever I found that the light was the brightest, that is where I taped my apparatus to the phone, so I can videotape and photograph it. I recommend doing this because it just keeps it steady and doesn't, by the shaking of your hand, your apparatus won't move. So now I'll show you what my interference pattern looks like. Right, so as you can see here, my camera is not very good at focusing, but your eye is, and you will be able to observe a very clear interference pattern from the two slits. As you can see, there is a central bright fringe, and then there are several other bright fringes that reduce, whose intensity reduces as we go further and further away from the light source. If this light source was not made coherent, not even if we hadn't even tried to make it coherent, we would not be observing this interference pattern. But as you can see, we have not succeeded in making this light completely coherent, because at the edges of these bright fringes, you can see these little spots of color. That is the interference observed with the lights of different wavelengths. So this is not completely coherent light, so of course our interference pattern is not very clear. But it does succeed in replicating Young's double slit experiment. As you can see here, the pattern for red light is more spaced out as compared to the pattern for blue light. It's not very visible, but you can apply the theory from how wavelength affects the width of the interference pattern in this demonstration, right? So the rest of the demonstration is just a video of what the interference pattern looks like. So I hope that the video of the interference patterns that I have obtained will give you some inspiration and some guidance when you are attempting this experiment on your own, because it can be very tricky to get a proper pattern of interference, and it will take you several tries. So even though this is a very arduous task, obtaining a good interference pattern with this experiment, I've tried to make it as easy as possible and to do it with items that you will definitely have in your home. Hopefully you are able to get an interference pattern as clear as I have shown it to you, and I hope that this video helps. Good luck on the experiment.